In today's lesson, we are mastering the discriminant of a quadratic polynomial. You will learn how to define the discriminant, use it to determine the nature of roots, and apply it to find unknown constants where lines and curves intersect. This is a critical pillar of the Cambridge 9709 Pure Mathematics 1 syllabus. It frequently appears in Paper 1, often integrated into questions about coordinate geometry or functions. Mastering this allows you to determine how many times a line crosses a curve without actually solving for the intersection points, saving you valuable time during the exam. By the end of this session, you will be able to confidently identify the nature of roots and solve inequality-based problems involving the discriminant. To understand the discriminant, we must look at the quadratic formula used to solve any equation in the form a x squared plus bx plus c equals 0. The part of the formula inside the square root is what we call the discriminant. We denote it using the Greek letter delta. The reason this expression is so important is that it discriminates or distinguishes between the types of roots an equation has. In mathematics, we cannot take the square root of a negative number to get a real result. Therefore, the value of delta determines whether our solutions are real or not, and how many of them exist. The value of the discriminant tells us exactly how many times the graph of a quadratic, a parabola, crosses the x-axis. There are 3 distinct cases you must memorize for your exam. In the first case, if delta is greater than 0, the square root in our formula gives a positive value. This results in 2 distinct real roots. Notice on the graph that the curve crosses the x-axis at 2 separate points. In the second case, if delta equals 0, the square root becomes 0. Adding or subtracting 0 gives the same result, so we have 1 repeated real root. Visually, the x-axis is a tangent to the curve, touching it at exactly 1 point, the vertex. Finally, if delta is less than 0, we are trying to square root a negative number. Since this has no real solution, the equation has no real roots. The graph never touches or crosses the x-axis. It floats entirely above or below it. Let's apply this to a specific problem. Find the nature of the roots for the equation 3x squared minus 5x plus 4 equals 0. First, we must identify our coefficients. A equals 3, b equals -5, and c equals 4. Now, we substitute these into the discriminant formula. Remember to use brackets when squaring the -5 to avoid calculation errors. This gives us 25 minus 48, resulting in -23. Since the result is -23, which is less than 0, we conclude that the equation has no real roots. In an exam, you must show the substitution and the final value of delta to earn full marks. Simply stating no real roots without the calculation will lose you the method mark. A very common exam task is finding the value of a constant that gives a specific nature of roots. For example, the equation x squared plus kx plus 9 equals 0 has a repeated root. Find the possible values of k. First, we identify the coefficients. The keyword repeated root is our mathematical trigger. It tells us that the discriminant must be exactly 0. We substitute our values into this equation. K squared minus 36 equals 0. To solve for k, we move 36 to the other side. Now we take the square root. Crucially, in Cambridge exams, you must remember both the positive and negative roots. There are 2 possible values for k. If you only provided +6, you would lose an accuracy mark. Always look for that squared term as a hint that there might be multiple solutions. Now let's look at a more complex scenario involving the intersection of a line and a curve. Find the set of values of m for which the line y equals mx minus 5 intersects the curve y equals x squared minus 4x plus 4 at 2 distinct points. To find where they intersect, we first equate the 2 expressions for y. We need to rearrange this into the standard quadratic form, ax squared plus bx plus c equals 0. Subtract mx and add 5 to both sides. Group the x terms to clearly see the coefficient b. Here, our coefficients are a equals 1, b equals negative open bracket 4 plus m close bracket, and c equals 9. The phrase 2 distinct points means our discriminant must be strictly greater than 0. Visualizing this, we have our curve. Substitute the coefficients into the formula, which simplifies to 4 plus m squared minus 36 is greater than 0. Expand the brackets. M squared plus 8m plus 16 minus 36 is greater than 0. This gives us m squared plus 8m minus 20 is greater than 0. To solve this quadratic inequality, we first factorize the expression to find the boundary values. The critical values are -10 and +2. Since we want the expression to be greater than 0, we look for the regions where the parabola is above the horizontal axis. This occurs in the tails of the graph. The solution is m is less than -10 or m is greater than 2. This range of values ensures the line is steep enough or positioned such that it always cuts the curve twice. Let's tackle a high-level question typical of the 9709 exams. The line y equals 2x plus c is a tangent to the curve y equals x squared plus 6x minus 5. Find the value of the constant c. Recall that a tangent touches the curve at exactly 1 point. This means that when we set the equations equal, the resulting quadratic must have exactly 1 repeated root. Therefore, our discriminant must equal 0. Step 1. Equate the line and the curve. Step 2. Rearrange into the form ax squared plus bx plus c equals 0. Step 3. Identify the coefficients. Step 4. Set the discriminant to 0 for a tangent. Step 5. Solve for c. The value of c is -9. In this question, using the discriminant is much faster than attempting to use calculus to find the gradient, especially when the line's gradient is already given as 2. To secure an A star, you must avoid these 3 common pitfalls seen in Cambridge scripts. First, the negative square trap. When calculating the discriminant for a quadratic like x squared minus 5x plus 6, many students write minus 5 squared as -25. Always use brackets on your calculator. A negative number squared is always positive. This single error can ruin an entire multi-mark question. Second, the missing solution. As we saw earlier, when you reach a step like k squared equals 36, do not just write k equals 6. The examiner expects both values. Forgetting the negative root usually results in the loss of the final accuracy mark. Third, the incorrect inequality sign. Students often confuse does not intersect with intersects at 2 points. Read the wording carefully. If the question says the line meets the curve, it could mean 1 or 2 points, so you would use delta is greater than or equal to 0. When sitting your paper 1, keep these practical tips in mind to maximize your marks. First, understand the marking scheme. Most discriminant questions are worth 3 to 5 marks. Method mark for setting up b squared minus 4ac. Accuracy mark for correctly substituting coefficients. Method mark for using the correct condition, like greater than 0. Final answer mark. Even if you make an arithmetic slip, writing down the formula b squared minus 4ac ensures you pick up the initial method mark. Second, always check the coefficient of x squared. If the equation is in terms of an unknown, such as kx squared, the condition a cannot be 0 is often relevant. If a becomes 0, the equation is no longer quadratic and the discriminant doesn't apply. Third, use the 2-step rearrangement rule. Never calculate the discriminant until your equation is perfectly in the form ax squared plus bx plus c equals 0. If you have terms on both sides, move them first. Mistakes in signs during rearrangement are the leading cause of lost marks in coordinate geometry questions. Finally, keep your inequality work tidy. If you reach a quadratic inequality, sketch a quick curve to decide if you meet the region between the roots or the regions outside them. Examiners love to see a small sketch as evidence of your reasoning. It is time to test your understanding. Please pause the video and attempt these 3 questions before we go through the solutions. Question 1. Determine the nature of the roots for the quadratic 2x squared plus 4x plus 2 equals 0. Question 2. Find the possible values of the constant p for which the equation x squared plus px plus 16 equals 0 has a repeated root. Question 3. Find the set of values for the constant k such that the line y equals kx minus 1 does not intersect the curve y equals x squared plus 2x. Pause the video now. Let us review the solutions. For question 1, we identify the coefficients as a equals 2, b equals 4, and c equals 2. Then delta equals 4 squared minus 4 times 2 times 2, which is 16 minus 16, equaling 0. Because the discriminant is exactly 0, the equation has one repeated real root. For question 2, the phrase repeated root means delta must be 0. Here, a is 1, b is p, and c is 16. So p squared minus 4 times 1 times 16 equals 0. This simplifies to p squared minus 64 equals 0. So p squared equals 64. Therefore, p equals 8, or p equals negative 8. Remembering both the positive and negative 8 is essential here. For question 3, we first equate the line and the curve. Moving terms to one side, we get x squared plus the quantity 2 minus k times x plus 1 equals 0. The condition does not intersect means delta is less than 0, with a as 1, b as 2 minus k, and c as 1, we have 2 minus k quantity squared, minus 4 times 1 is less than 0. Expanding gives 4 minus 4k plus k squared minus 4 is less than 0, which simplifies to k squared minus 4k is less than 0. Factorizing gives k times the quantity k minus 4 is less than 0. The critical values are 0 and 4. Since we want the region where the expression is less than 0, the solution is the region between the roots. To wrap up our lesson, let's summarize the essential points for your revision. First, the discriminant, delta equals b squared minus 4ac, is the part of the quadratic formula that determines the nature of the roots. Second, the value of delta tells you the number of real roots. Delta greater than 0 means 2 distinct roots, delta equals 0 means 1 repeated root, and delta less than 0 means no real roots. Third, graphically, delta equals 0 indicates that the line or x-axis is a tangent to the curve, touching it at exactly 1 point. Fourth, when solving for constants, always rearrange your equation into the standard quadratic form before identifying a, b, and c. Finally, remember that quadratic inequalities, often arising from delta greater than or less than 0, require finding critical values and identifying the correct range. Often best visualized with a quick sketch.